This is relatively harder kind of question that we need to use remainder theorem for. Okay, so let's read the question first. It says when p of x is divided by x minus 4, the remainder is 1. And then when it's divided by x minus 6, the remainder is 5. They want to know what is the remainder when divided by x minus 4 times by x minus 6. Now, what you need to realize is that x minus 4 times by x minus 6 is a quadratic. That means you got x to the power of 2 in this divisor. Okay, if you think about long division, why have any sort of polynomial divided by x squared as a divisor? Okay, what happens is you're going to keep on subtracting the powers by subtracting the powers, and at some point you might end up with some sort of x plus something, and then you start to realize, hey, x squared does not go into x, so I can't divide anymore, which means that this is a remainder. In another word, the remainder does not have to be a number. The remainder might be a linear equation. It might be a quadratic equation. It might be a cubic equation. It depends on the divisor. Okay, we actually came across one of this earlier in polynomial division of 3. If you go back to one of the previous videos, when we did this polynomial division, we ended up with a remainder of 3x plus 2. As you can see over here, this is not a number. The remainder is actually a linear function. Why is 3x plus 2? Is because we divided by x to the power of 2, and it cannot be divided, and the expression cannot be divided any further. Okay, so in another word, if I have any sort of polynomial divided by x minus 2, a linear, okay, I might end up with a remainder as a number. Now, if I divided a polynomial by some sort of x squared, okay, the remainder could be ax plus b. What that means is I might end up with an entire linear function as the remainder. If I have a polynomial divided by an x cubed expression, okay, the remainder might be ax squared plus bx plus c. The remainder might be a quadratic expression. Let's do one more. If a polynomial is divided by a 4th degree polynomial, then you might end up with ax cubed plus bx squared plus cx plus d. Okay, so your remainder could be a cubic expression. What that means is if the divisor is the 4th degree, the remainder can be all the way up to 1 degree less than. Okay, it can maybe will stop at 3rd degree. Okay, if the divisor's power is a third power divisor, then that means the remainder can go up to the 2nd degree, because once you get to the 2nd degree in the long division, you can't divide any further. In this particular case, because the divisor is a quadratic, okay, that means I might get a remainder that is a linear ax plus b. I might end up something like that. Now, with all that in mind, let's actually complete this question. Okay, so that means I'm going to get polynomial of x divided by x minus 4 times by x minus 6 will give me some sort of quotient of x plus the remainder, which is ax plus b. Okay, I don't know what a is, I don't know what b is, but let's find out. Now, based on the first condition, I know that polynomial, okay, p of 4 is equals to 1. Okay, p of 4 equals to 1 because when divided by x minus 4, the remainder is 1. What that means is if I substitute 4 into all the x's, I'm going to get 1. So what that means is 1 is equals to, I'm going to substitute 4 into all the x's here. Okay, I'm going to get 4 minus 4 times by 4 minus 6 times by some sort of quotient of x plus a times by 4 plus b. Okay, now 4 minus 4 is 0. That means everything here becomes 0. Okay, that's the beautiful thing about remainder theorem. All right, so then this means 1 is equals to 4a plus b. That's the first equation I got. Now let's look at the second equation. The second equation says that P6 is equals to 5. We got P6 equals to 5 because of the green condition. Okay, when it's divided by x minus 6, the remainder is 5. That means if I go back to the original polynomial and substitute x equals to 6 wherever I see it, I'm going to get 5. So 5 is equals to 6 minus 4 times by 6 minus 6 times by some sort of quotient plus a times by 6 plus b. Now 6 minus 6 is 0, which means everything here becomes 0. Okay, so that means 5 is equals to 6a plus b. We've got two equations. From here, it is simply solving two simultaneous equations. So we have, let's see, 1 equals to 4a plus b, and we have 5 equals to 6a plus b. If I subtract, I'm going to get 4 equals to 2a, and therefore a is equals to 2. Okay, if a is equals to 2, then b is equals to 2 times 4 is 8, so it must be negative 7. Okay, so what is the remainder? Don't forget what we're looking for the question. The question is figuring out what the remainder is, and we know the remainder is ax plus b, so that means it must be 2x minus 7. That is the remainder.